Hello, everyone. Today we need to have an introduction to deep learning. So we will try to talk about the basic concepts of deep learning today. So what is deep learning? In fact, deep learning or artificial intelligence, deep learning it's a sub branch or it's a part subfield of machine learning, and the machine learning on the other side also it's a subfield of artificial intelligence. So in fact, if we can talk about the definitions, AI is an effort to, can you hear me?
Yes, we can hear you.
So AI is the effort of to automate intelligent tasks normally performed by humans. So the goal from artificial intelligence is to try to develop a program, for example, which can perform at the level of human intelligence. This is the basic definition. So the field of AI is very broad, and it includes machine learning, deep learning, but also it includes many other approaches which that does not involve any learning. For example, if we need to build an expert system, for example, I mean, in expert system, it does not learn from data, for example, but it can learn from human, and this learning from human, it's not learning. In fact, it's in the form of rule-based reasoning, for example, or case-based reasoning. So we try to find how people solve the problems, and we try to get this knowledge and try to keep this knowledge in the form of this knowledge, and try to use it for building our expert system. So machine learning is a field of study which gives computers the ability to learn without being explicitly programmed. I mean, the problem of expert system, when it's not hard coded, in fact, but it's based on number of rules, and if those rules are not functioning, for example, we need to rebuild the system one more time, which might take time because we need to update our set of rules, and it will be really very complex when the set of rules is huge. It will be difficult to find which rule is working and which rule does not work, for example. So it will need too much time, and as I said, that it might be much easier to rebuild the whole system from scratch instead of trying to maintain the system. So deep learning deals with neural network with more than 2 layers. When it's 2 layers, we can call it shallow learning. When it's more than 2 layers, we can call it deep learning. So deep learning, it's not only convolutional neural network, but also it could be any feed-forward neural network with number of layers more than 2, for example, right? Compared to machine learning, deep learning can automatically extract features. I mean, when we are working with convolutional neural network, for example, I mean, when we are working with shallow learning, we try to make the problem easy for our problems. So we try to extract features which can make our problems easy to solve, for example. But when we are working with deep learning techniques, I mean, we don't need to work with feature extractions, because the neural network has those convolutional layers which will try to extract those features automatically. So in case of deep learning, we are working more with raw data, right? So in here, we are working with raw data. We don't need to do this data pre-processing and stuff. We need to work with raw data, and the task for the convolutional part, for example, will be extracting some relevant features. Machine learning model transforms its input data into meaningful outputs, a process which is learned from exposure to known examples of inputs and outputs. So when it's known examples of inputs and outputs, it means it's supervised. So when we are talking about this, it means it's supervised learning, right? So our neural network will be able to learn those mapping between inputs and outputs by exposing it to some examples which consist of inputs and outputs. So we need to have input features or inputs, not input features. We can just say that it exposing it to inputs and some labels. Those outputs, it will be labels, right? Okay. Yes. Oh, okay. I need to clean this. I don't know how can I clean it. I really don't know how can I clean my screen.
You click on that pane, and you have this upper bar. where you have the clear button.
One more time.
You have this pen symbol on your left. So you click there and you and the top bar shows up.
Okay, yes, I can do it. Yes, thank you. Okay, so okay, so this is an example. I mean, what does it mean in deep learning? So deep learning is a specific subfield of machine learning, as we agreed on, and it tries to learn some representations from raw data using successive layers to achieve meaningful representation. So, for example, when we look into this example with MNIST dataset, for example, this one, I don't know what is going on. So, okay. So, for example, here we have this original input, for example, which is this handwritten digits. It's MNIST dataset, for example, and this each image is 28 times 28 pixel values, and it's a grayscale image, right? So it's one channel, and we need to try to map this one into a digit, for example. So this one, it's a digit number 4, which is number 4 here. So we need to create this kind of mapping. So we will try to build a model. And this model will consist of number of layers, and each layer will try to learn some representations from the data using those successive layers to achieve those meaningful representation. So at the end, we need to classify each image into its target label, for example. So the deep learning is not a reference to any kind of deep understanding achieved by this approach, but it stands for the idea of successive layers of representation using literal layers. It's literal layers. Stacked on top of each other, and each layer will try to learn some representation from the original image or from the raw data. So deep learning technically is a multi-stage way to learn data representation. So this layer will try to extract some information, and it will send it, or it will deliver it to the second layer, and each layer will try to extract some meaningful feature representations from those raw images, for example, or from the previous layers, until we have this layer 4 here. We have in this layer 4 here, it will be the, maybe you can say that it will be the classification layer, for example. So this one will do the classification. So because it will convert those representations into a target feature, for example, into 4, 3, 2, into the digit. So each of those layers, layer 1, layer 2, layer 3, will try to understand or try to learn some representations from the data, which can be useful for creating the mapping between the inputs and outputs. So this is how we, for example, layer 1, it will try to learn some representations at the pixel level from those original input image, for example. So it will try to learn something. This one, maybe it's in some iterations. So in iteration 1, for example, we will try to get those representation, as you can see. So this is in the first epoch, for example, or first iterations. We will try to learn something. And as we train the model, at some point, the model will be able to learn some meaningful representations, right? When the model is trained. So this is maybe at iteration number 0, for example. This is at iteration number 20, for example. So by each iteration or at each iteration, each layer will try to learn some representations which can make sense for my problem. So at the end here, layer 3, for example, it will learn that, okay, this one has some pixel values or has a meaning. So, and those representation will be useful for layer number 4 to correctly classify this input image into specific digit, for example. When it's 1, it's when it's white, it's 1. When it's 0, it's when it's black, it's 0. So the pixel value. When it's 1, when it's white, it's 1, and then when it's black, it's 0, for example. So at the end, the output here in the output layer, we will have a vector. This vector will consist of 10 values. And as you can see here, those 10 values will be like this one. So it will be 0, 0, 0, 1, and the rest will be zeros. So it will be like this one. So we will have a vector. It's one hot encoding, and this vector, it will be zeros, unless at the index of this target feature label, for example, which is 4. So this is the index of 4, for example, because this one, it represents 0, 1, 2, maybe 0, 1, 2, 3, 4, 5, and so on. So it will be zeros everywhere unless otherwise at the index of this target table, for example. So the idea here is that each layer will try to learn something from those original image, and when it's at the initial stage, it will try to create some random representations, but with time, with training process, maybe those layers will try to extract some representations which can make sense for our problem. So how this training process will happen? We know it now. We have some input image, for example, or an input data. We will have those layers. The model consists of number of layers. Some of those layers will do some transformations. So first layer, for example, it will try to learn some representations from the input X, and it will send it to the second layer. The second layer also, it will try to do some other representations or transformations for those features. And finally, we will have the prediction layer. So we will have a layer which will do some predictions. We will compare between the predictions and the target, the true values. We will calculate the error loss function. This loss function, it could be mean squared error, or it could be any metric. Yes. So at the end, we will calculate this loss function, and we will use this loss function. We will try to minimize those loss function using the optimizer, and the optimizer will try to adjust the weights and the bias, for example, those weights and the bias of each layer in a way which will minimize this loss function. So at the end of this loss function, we'll try to minimize the difference between our predictions and our true targets, our predicted labels and our true labels, for example. And we will measure this using this loss function, and we will have an optimizer which will try to minimize, try to adjust those weights in a way which minimizes this loss function. So we know this process. We have here an example, just a simple example. We need to use, we need to build a deep learning model. It's not convolutional neural network, but it's just a feed-forward neural network which has, for example, some layers, some more layers, for example. But this model here, it's very simple. It's working with MNIST data sets. We need to build a model which can classify MNIST into its true target value, for example. So we will build a very simple model here. This model consists of two layers, one hidden layer and one output layer. So if we need to plot it, it will be like this one. We have one hidden layer, and this one hidden layer, it consists of 512 neurons, for example. So it's 0 or just 1, 2 until 512. And the output layer, it will consist of 10 neurons, right? Because we need to classify each image into one of those 10 classes, because MNIST dataset has 10 classes, 0, 1, 2 until 9. So we have 10 classes. So this one will be the hidden layer. This one will be the output layer. We will have those connections, and those connections are weights and bias, right? And the input layer here, I mean, the input layer, it's not physical layer. In fact, it's just a layer which transform inputs into the first hidden layer, for example. So we will have here the input layer, which will consist of the size of the input shape, in fact, of the image. And each image, it's 28 times 28 pixel values. So it's around 712. So we will have something here like this. So it's 1, 2, 3 until 712, correct? And it will just transform those into the next layer, for example. So in this case, so at the end, I mean, this model simply, I want to say that this model will be feed-forward neural network, and it has one hidden layer and one output layer. So if we need to build this model, and if we need to build this model, need to clean. Okay. If I need to, I don't know why it's not cleaning. Anyway, if we need to build this model, we will use sequential API from Keras, right? So, and we will add some dense layers. We will add some dense. It's not conventional neural network layer, CNN layer, but it will be dense layer, which is normal feed-forward neural network layer. So the first dense layer will has 512 neurons, as you can see it here. And we need to select what kind of activation. I mean, we will select ReLU. I hope if you can explain why do we need to use ReLU? Because this MNIST, in fact, MNIST images its pixel values, and its pixel value, it's a number between 0 and 255, correct? But we can normalize it. In fact, if you want to normalize, we can do normalization, and we can use another activation function, right? So the input shape will be 228 times 28. So each input image will be 28 times 28. And after that, we will use dropout. We use dropout with a dropout rate. The rate here will be 0.2. So it's a hyperparameter which we need to select. It could be 0.2, 0.3, 0.5. And we'll try to use this dropout layer because maybe we are expecting this model will overfit my data. So in this case, we need to use dropout to avoid this. We use dropout to try to minimize the model capacity, the learning capacity of the model, because maybe if the model is too complex and my data set or my problem is simple, maybe this model will overfit my data set very quickly. So to avoid this, we try to use a dropout layer. So we added here a dropout layer. Dropout layer does not have any parameters. It has only the only hyperparameter which we need to select is a dropout rate, which is number between 0 and 1. 0, it means 0%, and 1, it means 100% of those neurons will be dropped out. So we need to select number, would be close to 0.5, for example, which means 50% or 20% of those neurons will be dropped out, correct? 10% here, it means 51 units. 20% means around 100 or 102 units. After that, we will add another dense layer, and this dense layer, we will call it, you can name it also, so we can select a name for this layer, for example. Here we call it hidden layer, for example. You can just call it hidden layer or hidden layer 1, hidden layer 2, as you want. We will add another dense layer, which has 10 neurons. It's 10 neurons because this problem, we have 10 outputs. For this problem, in fact, it's one output, which is a digit, which is an actual digit. For example, it could be 0, 1, 3, 4, 5, but we can convert this one into one hot encoding. So we can convert it into a vector, which consists of 10 values, and 10 0 values, except at the index of this digit, for example. So when it's a 0, it will be 1 here, and the rest will be zeros. When it's 1, so the first one will be 0, the second one will be 1, and the rest will be zeros, and so on. So we use one hot encoding to make the problem simpler for my feed-forward neural network. So the activation function here, it will be softmax, and the softmax, we call it softmax layer because we need to calculate the probability. We don't need to classify, but we need to calculate the probability that this image belongs to that class, for example. And those probabilities will sum to 1. So at the end here, we will have 10 values, but those 10 values will be 10 probabilities, and the summation of those 10 probabilities will be 1. We need to give it a name. You can just call it output layer, for example. Just call it output layer to make it easy. And after that, after adding those layers, so we started with a sequential API. We added 3 layers. So the first layer, it's hidden layer, right? The second layer, it's a dropout layer, which does not have any parameters. And the third layer will be the softmax layer, which is the classification layer. So this is our model. I need to compile the model. I need to select a optimizer. I need to select a loss function. And we need to select a metric, which will be used. We need to use this optimizer to minimize this or maximize this metric, for example. It could be the accuracy or the prediction error, whatever. And we have very nice function, which called the model summary. It will summarize our model. So it will give you this table. So in this table, you will get the layer type, the output shape, and number of parameters in this layer. For example, for the first hidden layer, because we have only single hidden layer, so the first dense layer, it's hidden layer. So output shape, what will be the output shape from this one? We selected here 512 neurons. So the output shape, it will be 512. We should expect a vector which has a size of 512. What will be the number of parameters here? Can you calculate this number, please? Can you try to find this number? The number of parameters, it's number of weights and bias in this layer. Can you calculate this number? Can you try to find this number, please? For dropout, the second hidden or the second layer, it will be dropout layer. And the dropout layer, it's the same. We will have also the same number of outputs, 512, because this layer does not have any parameters. So number of parameters in this layer, it will be 0. But for this layer, for this hidden layer, can you calculate this number? Can you find this number? Yeah, if you know, please just try to open your mic and how can we get this number? And also for the output layer here, we have also the output layer. It's a dense layer. And this layer, the output shape is 10. We have 10 values out as an output from this layer. So we have 10. Number of parameters here would be this number. So can you calculate also this number?
It's 28 times 28 to get, what was that, 768, then times the number 512 plus 512.
Okay, this is very good. So it's 512 multiplied by the number of inputs, which is 28 multiplied by 28, correct? So this is the number of outputs from this layer multiplied by the number of inputs, which is 28 times 28. Yes, correct? Plus?
Correct.
512.
Yes.
So it's a number of weights. This is the number of weights, correct? And this is the number of bias, which we have. This is very good. What about the output layer? This number. So what about this output layer? Maybe someone else can answer it. You have to, yeah, for this number, it will be, I mean, it's for the output layer, and the output layer, we have 10 outputs. So it will be a number of outputs from the output layer multiplied by the number of inputs. So the number of inputs for this layer, it will be number of outputs coming from the previous layer, which is 512. So it will be 10 multiplied by 512, correct? Plus 10. We will get this number. So this is the number of parameters in this layer. So in this table also you can see a total number of parameters, which is a summation of those two numbers. So this is the total number of parameters. But this number can be divided into trainable and non-trainable. And you can see here non-trainable equals 0 because all those parameters will be trained. We didn't freeze any of those parameters. So number of non-trainable parameters equals 0, and trainable parameters equal to the same number here, which is 407,050 parameters, including weights and bias. So this is very important to know. I mean, this number, I mean, when we are working with transfer learning, we will get some non-trainable parameters here, because in transfer learning, we try to transfer a model from one problem to another problem. We try to use the same convolutional part and try to change or modify the classification part, for example. So the parameters from the convolutional part will be non-trainable. So when we are working with transfer learning, this number will be non-zero, right? So we will see this later on. We have also a very nice function which is called the block model. And this block model, you need to save it in a file. You need to select the extension, for example, .png, for example, or GPG, for example, and you will get this figure here. So this figure also, I mean, some people use it in their papers. Maybe I don't know if it's important or not important, but it will show you that we have one hidden layer, right? So this is my hidden layer. It's dense layer. The most important are dense layers here. So we have one dense layer, which is a hidden layer, and number of inputs to this layer will be 784, which is 28 times 28, because each input consists of, I mean, each image has a size of 28 times 28, and number of outputs will be 512. Also, the output layer, it's dense layer, which has inputs, and number of inputs will be 512, number of outputs will be 10. So if you need to calculate those known parameters, those number of parameters, it will be 10 multiplied by 512 plus 10. If you want to get this number here also, it will be 512 multiplied by 784 plus 512. We have here dropout layer, and this dropout layer, it means it does not have any parameters. Number of inputs or number of outputs equal to the number of inputs, and number of parameters equal 0, as you can see it here. The input layer also does not make any, it's not a physical layer, in fact. So this number of outputs will be the same as the number of inputs for this layer, and it does not have any parameters, this input layer. So we are counting from the first hidden layer, maybe the second hidden layer, the third hidden layer, and the output layer. The output layer, people, when they use softmax, they call it softmax layer, because it calculates probabilities. So usually people call it, it's a classification layer or it's softmax layer. And of course, we can try to get the confusion matrix, right? And this confusion matrix, we can do it for the test set. And as you can see here, it works very well for two with one hidden layer. So as you can see here, 971 from class 0 was classified as 0. For the class 1, for example, 1127 from 1 classified correctly, classified as 1. We have, for example, 2 ones misclassified as 0. We have, for example, 3 ones misclassified as 0 because some people, they write 3 similar to 1. To 0, for example, so sometimes people can get confused, and also the model itself can get confused. So the idea here in this confusion matrix, we try to build a model which can try to classify all those numbers across this diagonal. And those numbers, it's a true positive. Remember, true positive, true negative. So we need to maximize those true positive, true negative numbers, and the other numbers will be false negative, false positive. So if it was binary classification problem, you can just say that one class is positive, one class is negative. So it's a true positive, true negative. So it's a true 0, true 1, true 2, true 3, true 4, and so on. So we try to maximize all those numbers across this diagonal, and try to minimize other numbers. I try to clean those. Okay. Okay, so if you want to, sometimes people wish to see, the intermediate values. Sometimes it's exciting, in fact, to see those intermediate values from each layer. So if I want to plot my model again, so my model will be like this. I have one hidden layer here. I need to plot this hidden layer, for example. I have a hidden layer here, right? And I have an output layer here, correct? I know that the output from this output layer will be a vector, and this vector will consist of 10 values, right? So it will be like this one. It will be one vector, and this vector will be zeros everywhere except at the index of this target feature, for example, right? And I have those inputs here. So I have my inputs here. So the input image will be something like this one, 7. I apply 7. It's 28 times 28 pixel values. I will feed those pixel values to the first hidden layer. And after that, we will transfer those numbers to the output layer. So this one, it's the output layer. This one, it's the hidden layer. So sometimes people wish to see the outputs here. I will get here, for example, from this hidden layer, we will get a vector, and this vector will consist of 512 pixel values. Sometimes people want to see, how it looks like, for example. So if you want to do this, we have very nice function in Keras. It's called the model, right? We can use this one. We can use this one to try to split our model into sub-models. For example, I have my model which we used last time, but we need to try to get access to those outputs from each output hidden layer, for example. So in this case, I need to define a model because I can see the outputs here. I can see those this vector. So I don't have a problem for this one. For the input, I don't have a problem. So if I want to plot this digit, it's the input value. And if I need to plot this one, in fact, it's the output, correct? So this is the input. This one, it's the output. So the problem here, I want to get some intermediate values. And because I have only one hidden layer, so I just need to plot those 512. I need to get access to those 512 pixel values. And I need to put it as an image. I need to display it as an image, for example. So I need to reshape it. I need to reshape it into an image. So I will do this reshape into 32 pixel values multiplied by 16. This is it's a width and height, right? So or height and width, for example, it's a 32 times 16, for example. So I need to reshape those 512 pixel values into this shape, and I need to plot it. So this is the intermediate value which we need to plot. So if you want to get access to those values, you need to define a model, and this model, I will call it, for example, temp model, for example. And this model, it will has its inputs from the original, because I have a model called, I have another, the inputs will be the model.inputs, right? Because I defined the other model as a model, correct? So the inputs to this model, it will be model.input, and the outputs, it will be model.get layer. And I need to define this layer. We defined layers last time as a hidden layer. So I need to get the output from the first hidden layer. It's just hidden layer. This is the title of the layer or the name of the layer. We call it hidden layer. So I need to define a model, and the input to this model will be the model inputs, correct? And the outputs will be, because this is only one hidden layer, so the input will be the input to this layer. We need to define the inputs. So inputs will be model.input, and the outputs, it will be model.get layer dot output. But I need to define this, the name of this layer. It could be the name or the number, because it's the first hidden layer. So the number of this layer, it will be layer number 0. So you can just select it by number or select it by its name. So if we can go to the last example here, we have here a model. We defined the model, right? So the input to this new model, which we defined, it will be model.input, because here, this model here, when we combine this model, we have something called model, and this model has input. So I will define this new model here with M capital. The input to this model, new model, it will be model.input, right? And the output, it will be model.get layer. I need to define this layer dot outputs. So I need to get the outputs from that hidden layer. So in this case, we will try to get access to each hidden layer. If you have another hidden layer, maybe you have 2 hidden layers. So in this case, I need to define temp model 1 and temp model 2, and we will do the same. So the input to the model, it will be the input to my model, model.input, for example, and the output will be model.get layer, maybe layer 1, layer 2, layer 3, and so on, dot output. So in this case, we will be able to get access to those intermediate values if you want to see it. We need to plot it because to see the representations, what has been done after training my model. So this is the original input. And after applying this original input to my first hidden layer, which has 512 outputs, we will get this image, right? And after applying this image to my to the output layer, it will be converted into 10 values. And those 10 values, they are expected to be just 10 zeros, except one when it's matching the index of this image, when it's 7, for example. So the output vector here, it will be 1 when it's 2, right? It will be 1 when it's 1. It will be 1 when it's 0. So 0 here, it's the first index. So it will be 1 at that index, 0s elsewhere. This one, it will be 1 at the index of 1, 0s elsewhere, at 0 also, and so on, right? So if you want to see the representations, I mean, because this model has been trained, and we need to see what kind of representations the model has been trained. So when you look into it for this 512 values from the hidden layer, it looks like random noise, but it makes sense for my model, because in the output layer, it should be possible to try to convert this intermediate value into the right pixel value, which we need to classify. If you want to do this, I developed my temporal temp model, for example, and if you want to do some predictions, you can do some predictions using your original model. So it will be model.predict xtest, for example. So this is y prediction. So y predict here, it's those output values, if you want to plot it, for example. But for this temp model, after building this model, I need to apply number of input images. For example, I need to plot I need to see the images from 0 to 10, for example. So I will send it to this model, the test values from 0 to 10, for example. So the first 10 values, the first 10 images, and I will get this temp output. This temp output will be the temporary intermediate values which we want to plot here. So temp output, it will be those values. So this is the original. So this one, it will be xtest 72104. It will be xtest values from 0 to 10. So 0, it was 7, 1, it was 2, 3, it was 1, and so on. We have here 10 values, and those intermediate values, it will be temp output. It will be those intermediate values. The size of those intermediate values, it will be 512. You need to reshape it into an image, so we can plot it using image show, for example. So I will reshape it to the size 32 times 16. It's up to you to make any changes. For the input values, for the test values also, it's in fact, it's one vector. It's a flatten, right? So the x test value, in fact, for 0, it will be just one large vector, and the size of this vector, it will be 28 times 28 pixel values, but it's a flattened, so it's one vector. It's not an image anymore. So if you want to plot it again, you need to reshape it again into 28 times 28. In order to use image show, for example, for plotting it, so it will be x test. For example, dot reshape. I need to reshape it into this this way in order to see it in its original form. So we will do this one. So in this if for loop, for example, I need to plot for I in this range of n, which is the 10 values, because I applied X-test 10 values to this model because I need to plot those values. So we will, the first part it will display the original image. The second part it will display the encoded image, right? This is the encoded image, for example, or the feature maps from the first hidden layer, for example. And at the end, we need to display the, it's not reconstruction, but it's displaying the output, right? So predict, sorry, maybe I got this one from another code. So it will be displaying the Y predicted values. Predicted values. So it will be Y predict, and also we need to reshape it because it's 10 values. If you want to plot it as an image, for example, in this case, you need to reshape it as 10 multiplied by 1, for example, or in any way, in anyhow to make sense for you. So, and at the end, we need to have this plot show, so we can just plot those. So this example, it's a very nice example because you can use it for plotting those intermediate values and understand what will be the output from each hidden layer, for example. Yes. Now, do you have any question for this example? Do you have any questions for this example? It's just a very simple example. It's feed-forward neural network. It's not even very deep. But if you want to make it deep, you just need to add more hidden layers, right? Now I want to talk about data representation for neural network, because now we will be working with maybe images. We will be working with videos, for example. So we need to know how can we represent the data for our neural network. We need to use something called the data batches. And these data batches, for example, it's we need to divide my data into a batches. For example, if we need to use mini batch gradient, for example. So imagine that you want to use a batch size equal 128, for example. So in this case, you need to divide into your training data sets into a number of batches. Maybe so the first batch, it will be all images, maybe from 0 into 128, right? So it will be like this one. But if you want to divide it automatically, we can use this from NumPy, for example, array split, for example, XTrain, and the other input will be the length of the XTrain divided by the batch size. So you can just use that part here to divide your training data set into a number of batches. And in this case, we will get a number of batches. So you will get a batch, and number of batches here, it will be equal to the length of the XTrain divided by the batch size. Now I want to talk about the time series data and the sequential data, for example. Time series data, it's more complex because time matters here. So the time series is usually stored in a 3D tensor with an explicit time axis. This is very important because we need to keep axis of time. So the data set of, as an example, for example, if you have a data set of stock prices, for example, if we are collecting data each minute, and each minute we try to store the current price, highest and lowest price. So in this case, we have 3 values in each minute. So in each minute, we need to store maybe the current price, the highest price, and lowest price. So we have 3 variables here, right? And we need to store those values each minute. So each minute, we need to store a value. If we will keep storing those values for 1 working day, so 1 working day consists, for example, 6.5 hours. So in this case, how many different values from those current price, highest and lowest we need to store? It will be 6.5 multiplied by 60, for example. So it will be 390 values. So we will store those values into a 2D tensor. The shape of this tensor will be 390, 3, right? So because we have three variables we need to store, and we will store those values for 390 minutes each day, for example. And for how many days, for example, if we need to give those values for 1 year, for example, and 1 year has 250 working days, for example. So in this case, we will store it in a 3D tensor, and the shape of this tensor will be 250 days per year, for example. And each day has 390 values or 390 minutes. And in each minute, we store 3 values, which is highest, current, highest, and lowest price, for example, in each minute. Another example, which is a data set of tweets, for example, where each tweet is a sequence of 280 characters, because the tweet, I mean, when you are tweeting, for example, it has a limited size. And I guess they try to limit its size because you need to use machine learning for classifying it. We can use, for example, we can use machine learning to classify if those tweets are positive or negative, for example. So they limit it to 280 characters out of, and each character, in fact, is presented in English by one of those 128 unique alphabet. So each character, it could be one of those 128 characters, and those characters consist of all digits from 0 to 9, lowercase letters from A small to Z small, and uppercase letters from A capital to Z capital, and the punctuation symbols. So in fact, if you want to limit it to 228 characters, each character will consist of, it will be represented by a vector of 128 characters. It will be zeros everywhere, unless it's unless it will be 1 at the index of that character, for example. So if it's A small, if, for example, if I want to say, for example, Norway, for example, so in the capital, for example, so it will be represented by one character, one vector, and this vector will consist of 128 zeros, except at n capital, for example, it will be 1, and so on. So in this case, each tweet can be represented as a 2D symbol, a 2D tensor, right? So it will be, the size of this tensor will be 280 multiplied by 128, right? So if you want to represent each tweet, when you are writing, when people tweets, for example, so they have a limited size, limited number of characters, which is 280, but each character will be represented as 1 in a vector of 128 zeros, for example. So in this case, each single tweet can be encoded as a 2D tensor of shape 280 multiplied by 128, right? So imagine that we have a data set, and the data set consists of 1 million tweets, for example. So in this case, we need to store it in a tensor of a shape of 1 million. Each tweet of those 1 million tweets, it will consist of 2D tensor of shape 280 multiplied by 128 letters or characters, for example. If you have a data set which consists of images, for example, so each image, in fact, it consists of its width and height and number of its channels, correct? So each image will consist of this one, right? Usually, when it's RGB image, it will have 3 color channels. So it will be width multiplied by, it will be height multiplied by width multiplied by the number of channels, correct? So each image usually has 3 dimensions: height, width, and the color depth. This color depth, it will be 3 for RGB image, correct? And it will be 1 for maybe grayscale image, for example. So the grayscale image has 1-dimensional color channel, like MNIST dataset. So for example, MNIST dataset, it consists of, each image consists of 28 times 28 pixel values, and number of channels equal 1. So in fact, in reality, we can store it in this 3D tensor, 28 times 28 times 1. When it's RGB, it will be 28 times 28 times 3, for example, 3 channels, color channels. So in this case, a batch of 128 grayscale images of size 28 times 28, it will be represented as this one. Each image will consist of 28, the height will be 28, width will be 28, and number of color channels will be 1. But we have a batch of 128 grayscale images, so the size of this batch will be 128 multiplied by 28 multiplied by 28 multiplied by 1. So it will be the standard format, will be the sample, comma, height, comma, width, comma, color depth. So if you want to split, for example, MNIST dataset into batches, we need to do it like this. If you are working with video data, it will be the same as images, but because each frame will be an RGB image, for example, but we need to see how many frames per second. This is the so if you have a video data, for example, it will require 5D tensor, and it will consist of samples multiplied by number of frames, and each frame will have height, width, and color depth, correct? So for example, if you want to have a 60-second YouTube video, and each frame consists of 144 multiplied by 256, so the height will be 144, width will be 256, And of course, it's YouTube videos and it's color images. So it will consist of three. It's RGB image. Each frame will be RGB image, which consists of 3 color channels, for example. And imagine that each video clip sampled at 4 samples per second. So in this case, we will have 4 frames per second. So in this case, a 60-second YouTube video clip will be converted into how many frames we will have in those 60 seconds if each second has 40 frames, 4 frames per second. So in this case, this video, how many total frames will be in this 60-second video? It will be 4 multiplied by 60, because we have 4 frames per second, right? We have 4 frames per second. So how many frames? So it will be 4 multiplied by 60. So in this case, a batch of 4 such videos, what will be the size of, how can we store it? We need to store it in this 5D tensor, and we will have 4 videos, correct? And each video consists of 240 frames, and each frame has a size of 144 multiplied by 256 multiplied by 3, which is the RGB. This is the color each channels. So in this case, the total size, or the total, if you need to calculate the total size of this patch, for example, it will be 4 multiplied by 240 multiplied by 144 multiplied by 256 multiplied by 3 pixel values, correct? So we will have this total number of pixel values. If each pixel value is stored in 32 bits, in float 32, for example, so in this case, we need to multiply this number by 32 bits. And if you need to convert it into bytes, you need to divide it by 8. And if you need to convert it into kilobytes, you need to divide this number by 124. And if you need to convert it into megabytes, you need to divide the total number again by 124, and so on. So in this case, we can convert this number into megabytes. So this batch in this size, in this case, it will require 425 megabytes to store it, right? So if you want to use mini batch, for example, or batch gradient, you need to check your memory size, and you need to check, the size of your maybe training data set, for example. And if you need to decide how many batches, you need to start from the memory, how much memory you have in your computer, for example, or your GPU. And based on this, you will decide the batches. You can do it by trial and error, and even it's not working, you can just try to reduce the batch size, for example. But if you know your GPU RAM, for example, you can try to calculate the size of your data set, for example, and try to decide the batch size, because the batch size is very, very critical for your training process. But you can do it from here. You can, and also those numbers, if in your writing, in your paper, for example, if you can try to write something about this, it will be really very interesting, and it will be very educative for readers, for example. We can look into another data set, which is IMDb data set, and it stands for Internet Movie Database. It's a database which is used for reviewing some movies, for example. And it's used for sentiment analysis. So some people, they will give a review which is positive. Some people will give a review, for example, which is negative. So this is an example here. So someone, for example, says that we can start with a positive review, for example. This is a fantastic movie of 3 prisoners who become famous. One of the actors is, so this one, it's a positive review, as you can see, it's here. So in fact, usually people try to use recommendation systems, and those recommendation systems use machine learning. And instead of reading those reviews by people and try to convert it into positive and negative, we can train a machine learning model which can try to convert those reviews into positive and negative views, for example. So it's called sentiment analysis. In machine learning, we call it sentiment analysis. So you train a model, you have a data set, and this data set consists of those reviews. So one side, it will be the text, and the other side, it will be positive and negative. So in fact, it's a binary classification problem. So if I need to train a model for this, I just need to represent the text into a vector, because my machine learning model does not, know nothing about those text stuff. So I need to convert this text into a vector, and I need to build my machine learning model. And the input from one side, it will be this text, which will be just vector, for example. And the other side, it will be just binary classification problem, +1 and the -1, for example. So in fact, it's binary sentiment analysis, it's binary classification problem. So usually people use those reviews or data sets for training a model for sentiment analysis. And we can use it in some other applications. So for example, I can train it for movies, for example, and I can use it for, classifying the response from customers of a bank, for example. If they are happy with the service or they are not happy with it. I need to see how many of them are happy, how many of them are not happy with our services, for example. So I can build a model, I can train a model using this IMDB data set, and I can use it in some other application, for example. So it's a supervised data set, for example, and the input will be those reviews, and on the other side we will have those target values will be positive and negative. And once we train a model using this data set, we can use this model for classifying more reviews in the future, for example, or we can use it for classifying maybe some other things. So this data set, it stands for Internet Movie Database, and it consists of 50,000 movie reviews. It consists of 50K movie reviews for natural language processing application or text analysis, for example, and it's binary sentiment classification. It's binary classification problem, because at the end we need to classify each text into +1 and -1. And each review is a sequence of words of different lengths, because I don't ask people, if you want to be organized, in fact, you can ask people to put a review within a number of characters similar to tweets, for example. It makes life much easier for you, because I can just define. People will just try to put those reviews into. It will be more organized, because I can try to represent each review as a tensor of specific shape or size, for example. But usually people just let people write anything, for example, so the length will be different. Some people write very small text, and some other people write lots of text, for example. So each review is a sequence of words of different lengths converted into a sequence of integers. I need to convert those words into a list of, or a sequence of integers, where each integer stands for a specific word in a dictionary. Usually when you complete this data set, you try to select maybe the top 10,000 most popular words from this text, for example, and it will be your dictionary. And after that, you will convert each review into this vector, right? Because this vector consists of 10,000 words. In fact, it will be 10,000 zeros, right? And it will be 1 at the index of this word. I will go word by word, and I will see if this word exists in my dictionary. I will convert this word into the index of this word into 1, and the rest will be zeros. And I will do this for all my review for all words. So in this case, we will just try to represent each review as a one vector, which has a size of 10,000 zeros, and it will be 1 only at the index of that word. So in this case, or just this reviews, it will be 50,000, and it's divided into 25,000 for training, 20,000 for testing, for example, and each set consists of 50% positive reviews and 50% negative reviews. So it's a balanced data set, right? We have 50% positive, 50% negative. 50% will be used for training, 50% will be used for testing. And each review is a sequence of words, will be converted into a vector of 10,000 dimensional vector of zeros, except for the word indices, right? So the data set at the end will be represented as a 2D tensor of shape 50,000 movies, correct? I have those 50,000 reviews, and each review will be represented as one vector of 10,000 dimension, right? So at the end, it will end up with like this, right? 50,000 multiplied by 10,000 values, or each, you can say that each review will be represented by a vector of size 10,000. If we need to see an example, if you want to play with this one, you can get it from keras.datasets. So it's IMDB. You can get it from keras.datasets.imdb. You need to import load data and get word index, for example. So if you want to, and of course, we need to use this categorical cross. We need to use two categorical, because maybe we need to use one hot encoding at some place. So this function, if it's for one hot encoding, So we need to keep only the top 10,000 most frequent occurring words. Rare words will be discarded. So we just need to keep the most important words. And we created from this 50K reviews, we created a dictionary which consists of the most frequent words. Words which not most frequent, not very important, we will just ignore it, for example. So in fact, when we convert it into this vector of 10,000 values, maybe readability will be difficult, right? Because we will just keep the most important, most frequent words, and the other words will be neglected. So, I mean, it will be difficult to read it. So this is a data set. We need to load the data set. So it will be automatically divided into X train, Y train, X test, Y test. It will be 50,000 here and 50,000 here. 50%, sorry. 50% of it will be used for training and 50% will be used for testing. Number of words, it's equal 10,000, right? Which means each review will be represented as a vector of size 10,000. We will restrict the problem to 10,000 most frequent occurring words. The problem here, the lists or reviews are not of the same length. So we need to pad your lists to have the same length, correct? But if we will represent it as this number of, we can represent it as a vector of 10,000, right? And in this case, maybe you have some repetitions, for example. I don't know how they will deal with that. So we have 10,000 dimensional vector of zeros except for word indices. So we will do this part. We can vectorize X train, Y train. I don't know. Yes. We need to use this type categorical because we need to convert each one into we have its binary classification problem. So when we use this T categorical, we try to use one hot encoding. So each Y train and Y test will be converted into a vector of 2 values, right? So it will be like this one, 0, 1, for example, when it's negative, because this is positive, this one negative, and when it's negative, for example, negative opinion or negative view, for example, and then when it's positive, it will be like this one. Because this one it's positive, this one it's negative. So we will use here one hot encoding to represent each target value as a vector of 0 and 1. So in this case, when we are building our neural network, we can use this. The output layer. It should have 2 outputs, right? One positive and one negative, right? So this is an example. This is a review, which is a sequence of words. So as you can see here, it's very long. So this film was just brilliant custom location. I guess it looks like positive review, for example. So this is one review, which is a text and it's very long, and it's difficult it's difficult to control it because you just allow people to write things. So after that, we will have this coded review, which is sequence of integers. I will go word by word, and we will see. We will just pick words which exist in the 10,000 most frequent words, and we will write the index here. So we will convert it into this code sequence of integers. So this integer, for example, this one, it's the first word. For example, maybe this. I don't know if it's this or not. We need to check this. So, but maybe this it's the first word in this vector, for example, right? Film, for example, maybe it's 14, so it will be 14. Was, I don't know if was is important or not important. Maybe if it is important, it will be converted into a number here, which is 22, right? I have no idea. Maybe just it will be converted into 16 because this is the most important word in the 10,000 words, and it has a number of 16, for example. So in this case, we will go word by word, and we will convert this sequence of words into a sequence of integers, right? So we will have this sequence of integers, and after that, we will convert this one into a 10,000 value, a vector of 10,000 values in one hot encoding. So it will be one hot encoding of this one. So we will convert this one into one vector, and this vector will have a size of 10,000, as you can see it here, and all numbers are zeros except at the index of that word, for example. We don't have index 0, for example, we have index 1 here, so we have this one, correct? So it's 1. So it's a 0, 1, 2. For example, do we have here 2? We need to go through this one. Yes, we have 2 here, so it will be converted into 1 at 2. We need to check for 3, for example. Do we have 3? So it's 0, 1, 2, 3. We don't have 3 here. I'm sure that we don't have 3. So the 3 will be 0, for example. 4, it will be converted into 1. So we can look into that 1. If we have 4, we have 4 here. So at 4, the index at 4 will be converted into 1 because we have this into our text, and so on. And of course, it will also ignore repetitions. So if you have a word which is repeated, because we have here 4 one time, another time we have 4, another third time we have 4. So when it's repetitions, I mean, we will ignore it, for example. So in this case, we will convert each review into this one-hot encoding, which has a size of 10,000. So it will be 10,000 zeros, except at the index of the word. So in this case, life will be easy, because if you need to build a model, it's easy now. I can just build a model which has 10,000 inputs, right? So if I need to work with this problem in sentiment analysis, I know that each review will be converted into a vector, and this vector will has a size of 10,000 values. So if I need to build a model, I can just build a model, and I have the first hidden layer, for example. The input layer will be 10,000 values. So it will be I can start by 0, for example, or just 1. So x1, for example, x1, x2 until x 10,000, right? And I will just transfer those inputs into to the next layer, and so on. So now we need to build a model. So it's called the sentiment classifier. For example, I will use SK sequential API from Keras, for example. I need to build the model. So the input shape, we need to add number of dense layers. So I will have here one dense layer. It will be the first hidden layer. I didn't select a name for it, but you can put a name for it. For example, hidden layer 1, for example. So name equal hidden layer 1. So this layer has the input shape will be 10,000, right? Because we converted each review into a vector of size 10,000, right? So the input shape, it will be 10,000. The activation layer, it's up to you to use RALU or any other activation layer, but we use RALU because RALU performs well with vanishing gradient, for example. So, but it's up to you to select which activation layer you want to use, activation function you want to use. So the size of this dense layer, it will be 124, right? And it will be followed by a dropout layer, right? And after that, we will have another hidden layer, and this hidden layer has a size of 512, correct? And it will be followed by a dropout, and it will be followed by another layer, which is 256. So this one will have 256 neurons, for example, followed by a dropout. And the last one, it will be last hidden layer, it will have 64, and at the end, it will be just converted into it could be sigmoid or any kind of activation function you want, for example, and it will has 2 outputs, because we use the one-hot encoding, and we converted this binary classification problem into a vector of 2, right? So the output layer, this one will be the output layer. So this output layer will has two outputs, right? Positive and negative, right? We can use sigmoid, or you can use, last time here, we use the softmax. It's better to use softmax, in fact. It's better to use activation function softmax in this output layer, not this function, for example, but we use the here sigmoid, so no problem. But if you want to use softmax, it will be much better performance, because it will calculate the probability that this text is positive or negative, right? So it could be positive by 55% and negative by 45% or whatever, right? So it's much better to use softmax, and we call it softmax layer. So this will be our model, and after building your model, you need to to compile your model. You need to select your optimizer, and it's binary cross entropy because it's binary classification problem. We use this loss function, and you need to report your accuracy evaluation metric, which is accuracy, for example. If you want to use early stopping, you need to have validation loss, right? If you need to monitor this validation loss for early stopping, because maybe this model is too complex for our data and it will overfit. So you can just use early stopping before overfitting. And if you need to get model summary and the block model, as we did before, we can do it. So in this case, I will store this block model, I will call it imdb.png, for example. I will keep it into a file. Because we need to use early stopping, so it's very important to have this validation set, right? Correct. So in this case, we decided to use. I mean, it's from the X training, right? We need to divide the training set. We need to divide the training set into a training set and a validation set, because we use here early stopping. So we need to calculate the validation, not only the training loss and the training accuracy, but we need to have validation loss and validation accuracy. And here we will monitor validation loss. So for example, the first 20,000, it will be used for training, as you can see here. This one means the first training, the first 20,000 reviews will be used for training, and the last 5,000 will be used for validation, correct? Is it fine? So we divided this training. I mean, we agreed that the training set consists of 25K, correct? So we will use the first 20K for training and the last 5K for validation. And after that, we will train the model. So we will train the model using xtrain_ytrain. We will use 25 epoch. We will train the model for 25 epoch. The batch size will be 512, right? Because I mean, we use batch gradient. And the validation data, as you can see, you can select this one as a percentage, but here, in fact, we just selected X validate and Y validate. So the validation data will be that part. But in fact, you can just use a percentage, right, for validation here. Yes. And at the end, we will do model validation, right, using X test and Y test. So as you can see here, we can achieve accuracy for the X test and Y test. For the test set, we can achieve accuracy of 87%. And the model has been trained from epoch, maybe epoch 1 until epoch 4. And because we used early stopping, maybe it has been stopped at some point here. So we have this training, and we have in this figure the training loss and validation loss, and the training accuracy and validation accuracy. We just trained it for maybe for epoch because it takes too much time. Yes. We have also this Reuters data set, which is multi-class classification example. It's not binary classification. It's in LB also, but it's for multi-class classification, because we can, instead of, classifying those reviews into positive and negative, which is sentiment analysis, maybe you can convert it into different subcategories, for example. So this one is politics. This one it's talk about economy, for example. It's about piece of news. So this Reuters data sets, it's short new wires, and their topics published by Reuters in 1986, and it's used for text classification, and it consists of 46 topics, where some topics are more represented in it's unbalanced data set, imbalanced data set, and it consists of 46 topics. So we need to convert each piece of news into one of those 46 topics. And each topic has at least 10 examples in the training set. And the data consists of 8,982 training examples and 2,246 test examples. So this one, it's a multi-class classification problem, and it's in LB. And this is an example, xtrain 0, which is the first piece of news, for example. So it's something written like said as a result of its December acquisition, something. So we need to convert it also into we need to build a dictionary of the most frequent words, and we need to go word by word and convert each word here into each index, for example, if it exists in the table, and we will ignore words which does not represented in the dictionary. So we will convert this list of words into this vector, and this vector, it will consist of integers, and each integer will represent the index of the word if it exists in the dictionary, for example. So you can just go it word by word and just replace it with the integer value which represents this word if this word exists in the dictionary. Otherwise, we will ignore this word. And after converting this one into those integers, we will convert it into do you see this one in the background here? It consists of it's a vector of 10,000 zeros, and it will be 1 at the index. So for example, here we have 0, 1 here also. As you can see here, it's 1 because we have this one here 1. We have 2, for example. So this one, it will be converted 0, 1. Maybe 1 also, it will be converted as 1 here, and so on. So in this case, we will convert this sequence of integers into this one hot encoding. It will be 10,000. It will be a vector of 10,000 values, for example. If we will decide that we need to represent, we need to use 10,000 most frequent words in the whole data set to represent each piece of news, for example. So it's similar to the IMDb data set. And the output, we have how many topics we have? 0, 1, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 4. So, I mean, we have those 46 topics, maybe, I don't know. Maybe it's those 46 topics. So it will be converted into this topic index, right? And for example, this text, it belongs to topic index 3. So it will be 0, 1, 2, 3. It will be 1 at 3 and the zeros elsewhere, right? So if we need to build a model for working with this problem, we need to load our data set also, writers.load data from Keras, and number of words which will be used to represent each piece of news. It will be 10,000 words, similar to the other example. So the word index, it's Reuters.get word index, for example. This is the reverse word index. We have a dictionary, so you can just run that code, right, to decode each news wire, right, into a list of integers, and after that we will convert it into 10,000. We will convert this index into a vector of 10,000 values. It will be 1 if this word exists in the sequence. Otherwise, it will be zeros, right? So in this case, we will convert each new wire into this 10,000 into this vector, which consists of 10,000 values. We need to convert because we have those 46, maybe 46 categories. We have those 46 topics. So we need to convert. We need to. I mean, the output X train and Y train. It will be just a list of numbers from 1 to 46. We need to convert this one into one hot encoding. So we will use this 2 categorical. So in this case, we will just convert its Y train and Y test into one hot encoding. And in this case, each Y train and Y test will be converted into a vector of 46 values. So it will be 46 zeros except 1 at that category, which it will be 1 at the category, the specific category of this news wire, for example. We need to build our model. We will use sequential API, and we will add some dense layers. So for example, the first dense layer, it will has 128 neurons. Number of inputs will be 10,000. I mean, the input chip will be 10,000 because each news wire will be represented as a vector of 10,000 values, right? We will use, it will followed by dropout. After that, we will have a dense layer which has 32 neurons. Number of input, we don't need to mention the number, the input shape here because it's already will be inherited from the first dense layer. And at the end, we will have this softmax layer, which is the classification layer. And this one will consist of 46 neurons, which means it will provide us with 46 values because we will use this one hot encoding. So you will compile your model. You just select your optimizer, for example, and select use loss function, categorical cross entropy, the metric which will be used for evaluation. We can use model.summary and also plotting, I mean, this plot model, for example, and then we will train the model using X train, Y train, and the validation split, right? So last time when we are training this model, we will select this validation data. So the validation data consists of X validation and Y validation, but you can select it as a percentage, right? So it will be here, the validation split equal 20%, which means 20% of the X train, Y train will be used for validation. If we need to understand this table, it's the same. Our model consists of 3 hidden layers. So this is the first hidden layer, second hidden layer, and two hidden layer and 1 output layer, in fact. So this one, it's output layer. This one, it's output layer. And we have 3 hidden layer. It's nice to add a name for it. So this is the hidden layer number 1, hidden layer number 2, and hidden layer number Yeah, in fact, we have only two hidden layers. So hidden layer number 1 and hidden layer number 2, and we have two dropout layers. So if we need to calculate those numbers of parameters here, so can you calculate this number, please? So this one, it will be number of outputs, which is 128, right? Multiplied by number of inputs, which is 10,000. The input dimension is 10,000, so it's multiplied by 10,000 plus 128 buyers, right? So it will be 128, 1,280,128. For the dropout, number of parameters will be 0. For the second layer, which has 32 outputs, so this number, it will be 32 multiplied by 128. It will be 32 multiplied by number of inputs to this layer, which is 128 plus 32, and so on, right? Please let me know if you want to take a break. Maybe we should take a break, but we can just finish that part and take a break. So now we will train the model. So we will have here the training loss and the validation loss. So, I mean, because we will train the model for 20 epoch, for example. So we will start at maybe epoch number 0, for example, right? So as you can see here, the training loss is very, very high, and the validation loss also is that value. And as we train the model, those numbers will go down, right? So now we can see that the training loss, it goes down, and also the validation loss, it goes down, right? This is the training and validation accuracy also when we are starting. I mean, the validation accuracy is very low. Training and validation accuracy are low, and the accuracy will increase with time. At the end, we need to plot the confusion matrix. You can see here, this is the confusion matrix, but because we have 46 topics, right? So it's difficult, in fact, to display it. But you can see here all numbers. We have only our topics located in the this diagonal. Other numbers, usually it's zeros, for example. So it's and some topics are more represented than other topics. So some topics are more dark than other topics, which means we have more topics from more examples from some topics compared to the other topics. So this is the training and validation and the testing loss and accuracy. I don't know how this number is 1.2. I need to check those numbers, because if it is percentage, it should not be more than 100%. But I need to check, I mean, what kind of function which we use. Yes. Yes. So I guess we can stop here, but if you have any questions, please, do you have any questions before we can take a break and we can start in deep learning, convolutional neural network in the next part? But if you have any questions, please, do you have any question for that part? Any questions? Okay, so in this case, we will stop here and we will start after 10 minutes. Thank you.